Assalamualaikum. Hi guys. Now I'm going to continue my video about hydrogen bond. Hydrogen bond is a strong permanent dipole-dipole attraction between positively charged H atom and negatively charged of electronegative atom for another molecule. So maknanya kita akan nampak attraction tu adalah antara H2O daripada one molecule with another H2O daripada another molecule. Sebab tu kita panggil intermolecular forces between molecule. So hydrogen bonding akan berlaku apabila awak ada dalam molekul iaitu the most electronegative atom. Hanya ada 3 sahaja FON. So short form untuk saya bagi tips kepada awak untuk ingat, kita perlu ingat handphone. So handphone ni maksudnya hydrogen bonded to fluorine, hydrogen bonded to oxygen or hydrogen bonded to nitrogen. Bila dia ada hydrogen bonded kepada salah satu daripada atom ini, maknanya dia boleh form hydrogen bond. So kita boleh lihatlah dekat sini, oxygen daripada first H2O molecule akan ada attractive forces with hydrogen from another H2O molecule. Syarat seterusnya, we should understand that syarat yang paling penting, as I mentioned before, H atom mesti attached to phone atom. Ataupun lagi satu, dia mesti ada unshared pair electron iaitu lone pair on electronegative atom. For example, kita lihat H2O, the most electronegative atom adalah oxygen dan awak boleh nampak ada 2 lone pair untuk setiap water molecule. Next, you should understand as well how to identify whether these molecules below akan hasilkan hydrogen bond ataupun tidak. Syarat dia kita kena lihat H atom bonded kepada phone. So you can see that from here, dia boleh form hydrogen bonding between these molecules. Next, saya ada juga contoh lain macam alkohol. Alkohol pun boleh hasilkan hydrogen bond di antara O dan H atom here. So dia ada between two alcohol molecules. So this is hydrogen bond. Next, hydrogen bond juga boleh berlaku antara carboxylic acid. Macam mana? We have this hydrogen with oxygen daripada another carboxylic acid. So inilah hydrogen bond kita. Next, we can also identify hydrogen bond between amines. So amines kita ada nitrogen yang ada lone pair. So lone pair ni dekat nitrogen ni dia akan tarik attractive forces akan terbentuk with hydrogen from another amine molecule. So ini cara untuk kita identify examples of molecule that can form hydrogen bonding. However, ada certain molecule juga dia tak boleh form hydrogen bonding. Contohnya macam this one. So kita ada hydrogen bond between CH3OH, tapi bila CH3OH with methane, kita nampak methane adalah CH4. So dia ada hydrogen, tapi this hydrogen is not bonded to F ataupun O ataupun N. Dia hanya bonded kepada carbon. So dia tak boleh buat hydrogen bond with CH3OH. Next, we are going to discuss about strength of hydrogen bond which are affected by two things. Yang pertama adalah polarity, iaitu di mana if you get more highly electronegative atom, the stronger the hydrogen bond. So the strength of hydrogen bond in HF is stronger than NH3 because fluorine is more electronegative than nitrogen. So saya harap awak masih ingat phone kita ada fluorine is the first top one electronegative atom followed by oxygen dan nitrogen. Seterusnya, the second factor that can affect the strength of hydrogen bond is extensiveness. Extensiveness ni apa maksud dia? Dia bermaksud sekiranya awak ada more hydrogen bond per molecule, maknanya more energy needed to overcome it. For example, saya ada water. Water can form 4 hydrogen bonds per molecule. while HF can only form 2 hydrogen bonds per molecule. Therefore, boiling point untuk water is higher than HF. So, masih ingat lagi this flowchart, sekiranya awak nak tentukan type of intermolecular forces yang wujud dalam certain molecule, you have to follow this part. First thing first, no matter what, you have to determine the polarity of molecule first. Sekiranya dia non-polar, automatically dia adalah London forces. Sekiranya dia polar, you have to take a look whether ada hydrogen atom yang bonded kepada phone ataupun tidak. Sekiranya ada, dia boleh form hydrogen bonding. Sekiranya tiada, it can only form water dipole-dipole forces. So I leave it try this 1.0 so that you can understand how to identify the intermolecular forces in certain molecule. So now we are going to continue with the effects of hydrogen bonding on physical properties. There are 3 physical properties that we will discuss. The first one is boiling point, the second one is the solubility, and the third one is density of water compared to ice. So kita ada this graph. If you take a look here, this is the trend for boiling point of hydrides based on element in group 14 until 17. If you take a look here, you got this one, group 14, and then you get next one, group 15, 16 until 17. So graph ini akan kita gunakan to discuss about the boiling points of hydrides. So let's go to the first discussion. You have boiling points of hydrides for group 14. Dia displays normal behavior di mana CH4 is the lowest boiling point dan SnH4 is the largest boiling point. This is because the type of intermolecular forces exist between this molecule hanyalah van der Waals forces. So jangan lupa perkataan van der Waals forces, spelling dia mesti V small letter and W capital letter. Dalam kes ini, hydrogen bond tidak wujud. So dia akan increase regularly for boiling point when the molecular mass increases. Because kita dah belajar sebelum ni, dalam video sebelum ni, sekiranya molecular size increase, maknanya van der Waals forces also increase. Next, we go for hydrides in group 15, 16 and 17. Except for ammonia, water and HF, kita boleh lihat dekat bahagian sini, hydrides ini mempunyai boiling point yang makin bertambah when going down the group. So the increase in boiling points for hydrides is due to the increase of van der Waals forces kerana molecular size itu makin bertambah. Dalam kes ini masih lagi tiada hydrogen bond. Next we go for the third part di mana boiling point of ammonia dekat sini, you can see this is the ammonia. So ammonia, water and hydrogen fluoride, they got strangely high boiling point compared to the other hydrides. This is because of the existence of hydrogen bonding which are more stronger than van der Waals forces. So kalau kita lihat ammonia, dia boleh buat hydrogen bond, water pun boleh buat hydrogen bond, sama juga dengan hydrogen fluoride. So bila dia boleh buat hydrogen bond, maknanya awak boleh nampak dekat sini boiling point itu akan makin bertambah. So bila bertambah, yang mana yang paling tinggi? Yang paling tinggi adalah water. Dan strength of hydrogen bonding depend on electronegativity of fluorine, oxygen and nitrogen. Strength of hydrogen bond bergantung kepada electronegativity, iaitu HF yang paling tinggi, followed by water dan ammonia. So kalau lihat daripada figure ni, we talk about general statement, HF patutnya paling tinggi lah kan. Cuma bila you take a look at this graph, HF adalah yang second one, sebab yang paling tinggi adalah water. Kenapa macam ni? This is because water can form 4 hydrogen bondings compared to HF yang boleh form 2 hydrogen bondings. So that's why water paling tinggi. and then HF akan jadi the second one compared to ammonia, sebab ammonia boleh buat satu saja hydrogen bonding per molecule. Now, settle untuk effects of hydrogen bonding on boiling point. Kita akan continue with the second effect, which is solubility. So, water is a good solvent for liquids and gases because water is a small polar molecule. It can form hydrogen bonds with water molecule. When we talk about hydrogen bonding in boiling point, dia maksudnya dia antara molekul dengan molekul. Tapi sekarang, untuk solubility, dia adalah antara molekul with water. So, untuk case ammonia soluble in water because ammonia juga boleh form hydrogen bonds with water molecule. For example, kita boleh lihat dekat sini, this is ammonia and this is water molecule. Sebab we talk about solubility right now, bukan lagi boiling point. So, most organic compounds are insoluble in water, except for alcohols, carboxylic acid and amine. Hanya 3 ni sahaja organic compound yang soluble. Yang lain insoluble. So, alcohol and carboxylic acid are soluble in water because OH group dalam compound diorang. Dan OH group tu boleh form hydrogen bond with water molecule sebab H ini bonded kepada most electronegative atom, dalam kes ini adalah oksigen. Contoh, saya ada amine. Amine juga soluble in water because NH2 group in amine can form hydrogen bonds with water molecule. For example, saya ada this amine, dia ada NH2 group here. So, NH2 group here can form hydrogen bond with water molecule. So, that is the general fact. However, not all organic compounds that contain NH2 group or OH groups are soluble in water. This is because we will discuss a bit about relative molecular mass. Sekiranya relative molecular mass increases, polar OH and NH2 group become smaller because non-polar hydrocarbon portion becomes larger. So, bila hydrocarbon ni larger, dia akan ada hydrophobic area yang tidak suka air. That's why solubility itu akan berkurang. So, bila dia berkurang, maknanya dia efek daripada higher molecular mass. So, higher molecular mass ni bergantung kepada number of carbon atom. So, conclusion dekat sini, macam mana kita nak faham? Contoh, saya ada CH3OH. It can form hydrogen bonding with water molecule. However, kita ada hydrophilic area dekat sini yang suka terhadap air. Sebab tu dia form hydrogen bonding. But if I have carbon, di mana carbon dia ada 5 carbon attached to NH2 group dan 5 carbon attached to OH group, hydrocarbon ni adalah molekul yang consist of carbon and hydrogen atom sahaja. Bila nilai ataupun bilangan carbon atom semakin bertambah, maknanya hydrophobic area juga makin bertambah. So that is why dia punya relative molecular mass yang makin bertambah itu akan decrease the solubility of organic compound when reacts with water molecule. So settle untuk solubility. Now we go for the last part, which is effect of hydrogen bonding on density of ice. So density of ice ni macam mana? Kita faham dulu tentang water. Water akan menghasilkan ice sekiranya dia lalu proses freezing. So right now you can see this is the molecule of water. Maximum water boleh buat hydrogen bond adalah 4. Okay, dia boleh buat 4. Sebab ada satu daripada H kat sini. So, dia boleh buat 2 sebab hydrogen atom ada 2. Dan kita ada lone pair on oxygen atom. Sebab tu 2 lagi hydrogen bond. So, bila kita faham tadi, ice akan terbentuk when water cooled to a solid. So, in this part, water molecules will arrange themselves to form tetrahedral arrangement so that it can maximize the amount of hydrogen bonding between them. Dalam kes ini dia akan meninggalkan a relatively large amount of space between them. Dan space ini kita akan panggil open structure. So this arrangement of molecule has a greater volume than liquid water. Thus, water expands when frozen. Sebab tu kita akan nampak bentuk ais tu mengembang apabila dia sudah beku daripada liquid water. So how open structure looks like? Sebenarnya bentuk dia macam this one, di mana awak boleh tentukan open structure daripada this arrangement. Kalau 3D dia dalam bentuk macam ni. So each of these adalah merujuk kepada satu water molecule. Yang merah ni dengan dua bonding pair. So this open structure of ice accounts for the fact that ice is less dense than water. Maknanya ketumpatan dia lagi rendah daripada water. Sebab tu bila kita campak ais dalam sungai, ais itu akan terapung sebab dia less dense than water. And then kita sambung lagi, bila ais tu cair, some of the hydrogen bonds are broken. So this allows water molecules to be more compactly arranged, resulting 9% decrease in volume. So when volume decreases, density will increase. Because the formula for density is equals to density mass over volume. That's why dalam kes ini water has higher density than ice. So maknanya benda yang samalah macam yang saya explain tadi. So dalam kes ini awak boleh nampak lah this graph, water is a very unique substance dan kita akan fokus more about this graph in the next chapter. And you can see that dalam kes ini density untuk water paling maksimum adalah 1.0 gram per mililiter. Dan dekat sini dia punya temperature is 4 degrees Celsius. Dan daripada sini, apa maksud 4 degrees Celsius ni? 4 degrees Celsius ni merujuk kepada maximum density for water. So that's why water is a unique substance. We will focus more about this one in the next chapter. So until here, you've learned a lot of facts about hydrogen bond, how to identify hydrogen bonding, and the effects of hydrogen bonding based on boiling points, solubility, and density. I leave it, try this 2, try this 3, try this 4, try this 5 for your exercise. Try to complete this one and try to do a lot more practice how to understand about this concept. So that's it for now. I will see you in the next video. Bye!